Hello, everyone. This is Haoqun Jiang. Thanks for joining me today. Today, I'm going to talk about managing complexity in Vue CLI. First, let me introduce myself. I'm Haoqun Jiang from the Vue.js Core Team. I currently work full-time on the Vue.js related open source projects. And aside from Evan, I'm the only full-time open source developer in the core team. Most of the time I work on Vue.js build tools such as Vue CLI and its related projects like Vue Loader for Webpack and the JSX Plugin for both Vue versions. Also, I plan to start working on Vite tool later this year. You can reach me at Soda.t on GitHub. My Twitter handle is Haoqun Jiang. That's my full name. So let's get back to the main topic here. The title of today's topic is about managing the complexity in Vue CLI. You might be wondering, so what's so complex in a CLI? After all, it seems that it's just a thin wrapper of a Webpack, right? But in reality, it's much more than Webpack. If you look close to this graph, you may see that we intend Vue CLI to be the standard tooling for Vue.js development. That is to say, it is involved in every phase of your project development, from project setup to development in the browser and unit testing, end-to-end testing, and the final bundling process. It integrates dozens of front-end tools. Though Webpack is used in many scenarios, especially in its dev server and the bundling utility. But the hard part is not Webpack itself, but to make so many different tools of different purposes to work together. We have several languages, including TypeScript and JavaScript to support. We also need to support both Vue versions and all kinds of linting formatting tools. And we need to provide a consistent project structure across all the apps. That is the hard part. So for all those features included, we now have a whole lot of packages to maintain. The direct dependencies in the Vue ecosystem is Vue Loader, and we have the Babel preset and plugin for JSX support. And for some of you, you might need to build your Vue component into a web component. So we have a web component wrapper to maintain. And inside the CLI, we have more than 10 core plugins and several ESP configs. That's already a huge collection of packages to maintain. But even more, we need to take control of several forked community packages because the upstream may be fully maintained, like the preload Webpack plugin and the friendly arrows Webpack plugin. So with so many packages to maintain, it's already a huge burden on us. And yet more, we have a graphical user interface. So which is part of the Vue.js CLI itself. And this wide range of scope makes our job extremely challenging. So, and during the time of maintaining those projects, Vue CLI also have seen a steady growth of user adoption. In the last 2 years, the weekly download count has been more than quadrupled. It starts from less than 200,000 downloads per week to now about 800,000 downloads per week. Yet we have a small number of maintainers. you can see in the graph that only about a dozen people have contributed more than 10 commits to the repository. So with a growing responsibility and user base and a yet small team, we now have to make project maintainability as our highest priority. So let's now talk about how to achieve this goal. First, I want to talk about the situation that I call it configuration fatigue. For every new front-end project, you may see many files starting with dots or ending with .config, .js, or .rc at the root directory, like in this picture. Many users may be frustrated by the number of files at the first glance. This has also become a pain point in us maintaining VueCLI versions, because for all those file formats, whenever we want to ship changes to a specific config of a specific tool, we need to write a bunch of code to scan all the possible formats so as to change the config in a safe way. We may deal with the JS, JSON, or YAML or init files, and a lot more. This is the most obvious type of undue complexity. This could totally be avoided. So luckily, many of the config files are not mandatory to be standalone files, like those in the red squares. So we started by trying to move those files into package.json. And now we have reduced the config files in the root directory to a few. This is because most of the time, users don't need to touch those configurations. So we don't have to show them to those actual complexity at their first glance. And secondly, by moving to package.json, we manage those configurations in their JSON representations. These plain JSON objects are much easier to manage. That is to say, they are much easier to create and modify than the original JS or even other custom file formats. So internally, VueCLI manages those configurations just as plain JSON objects. And whenever we or the user need to use a standalone file, we create those files from the JSON object. That is the first step to keep the configuration clean and concise. But as you can see, when we move those configs to package.json, the package.json file itself has been bloated. So we need to simplify those configuration objects even further. So here comes the presets. Most front-end tools that are complicated enough to have dedicated configuration formats will also support some kinds of presets. We can start by trying to move all those configuration setup from the user project to the CLI internal logic. The left shows the config generated by an earlier version of VueCLI, and the right is the current preset used in the VueCLI projects. Tens of lines of code has been eliminated. It is moved from the user project to the VueCLI plugin internals, and we can do this for other tools like Babel too. Please note here that these presets aren't in separate packages. They are imported from the plugin internal. They should be seen as plugin defaults, just exposed in a way that users can extend from. An obvious benefit of using presets is that we can fix bugs and add features without user interaction. And the Vue version, and we managed to add Vue 3 support without releasing a new major. We just detect the Vue version in the user project and automatically redirects the default preset to the Vue 3 corresponding one. The reason we do this, we use the presets is that as defaults is that I think I believe that zero config isn't always feasible, especially given the context of Vue CLI. We need to support all kinds of customization, and the users need to have access to these default configs. So we have to expose some kinds of configuration to the user directly, but we can provide them in a concise way, and the concept can be simplified. So these one-liners as presets are good defaults in the plugins, and good defaults can also make life easier. The second major source of complexity in the CLI development, I think, is the unpredictable dependencies. If your app has to support IE11, you might be familiar with this error code, script 1002 syntax error. This is usually caused by an untranspiled error function in the vendor's trunk. That is, a file containing an error function failed to get transpiled because it's inside node modules, and thus it's untouched by the Babel plugin. This is one example of unintended behaviors caused by third-party code. So in Vue CLI 3 and 4, we used a transpiled dependencies option to help solve this problem. But this introduces another level of complexity, because to use this option, you need to know exactly which dependencies is to blame. So in Vue CLI 5, we try to solve this problem in a different way. There will be a transpile depth command line flag, which is enabled by default when you execute any Vue CLI command. By enabling this flag by default, both users and we as CLI maintainers no longer need to identify each of the problematic third-party packages. Mental burden is thus removed. Of course, it comes at a price. This feature will bring much performance overhead compared with that of only transpiling selected dependencies. And your build speed will be slowed. But as Vue CLI 5 comes with Webpack 5 and has a better caching mechanism, we consider the performance overhead would be tolerable later with the consistent file system caching. That's why we only introduced this flag in CLI 5, because it uses Webpack 5 and has those performance improvements. The other type of problem caused by third-party code is the problematic third-party type definitions. Oftentimes, if a third-party type definition uses some experimental features in a new TS version newer than the one used in the user project, or it has included some inaccurate type definitions from older versions, or has some bugs, there is a large chance that your code, your correct code would encounter some unexpected errors, TypeScript errors. There's no easy way to work around such problems. We can't always easily augment the type definitions from node modules. Yet such issues occurs very frequently because the current TypeScript ecosystem is still evolving very quickly, and yet it is still imperfect. Even in Vue 3, which is developed in TypeScript, has caused some type issues in the past. So we have to find a way to keep our project from being affected by such annoying problems. Then here comes the skip lib check option. When it is enabled, it will TypeScript will skip all .d.js type check-ins. That includes the one in the user project and all those from the node modules folder. At the first glance, this seems at odds with the intention of TypeScript, right? Because all the reasons we use TypeScript is to check our code against the types. Why would we want to skip the type checking altogether? But actually, it is recommended by the TypeScript team. It is on by default with tsc init command since 3.9, TypeScript version 3.9. The logic behind this is that third-party type definitions should be used for code completion, not for type checking, because those type definitions would be very helpful if we only use them for IntelliSense, for checking available options and deprecated types. But when used as a tool to check your code, it have many unintended consequences because of the imperfectness of TypeScript at the current stage. So we should isolate third-party TypeScript from our project code. Another way to keep the project maintainable is to launch new features in a manageable way. Here, I'll give several examples. For example, Vue CLI has supported Vue 3 in a minor release last year. When we started to implement this feature, the Vue 3 ecosystem is still in flux, so there are many temporary logic in the initial setup. If we ship this into the core package directly at that time, it would make the core plugin in a mess and may force us to ship breaking changes later. So we chose to ship a separate Vue Next plugin first. And after its features stabilized, we moved the logic into the core package. And since then, the logic has been rarely touched because it's quite stable. And the original plugin was since deprecated. So this way, we have successfully keep the complex logic complex experimental logic in a separate scope. Plugins can not only be used for experimental new features, but also for providing legacy feature support. In Vue CLI 5, we ship the CLI with Webpack 5 by default, but it is understandably that many of the ecosystem packages hasn't caught up with Webpack 5 yet, including the popular Webpack. Many of the users may want to stay on Webpack 4 for a while, but if we mix the Webpack 4 logic and the Webpack 5 logic in a single package, it would be a nightmare for us to maintain. So in Vue CLI 5, we shipped a separate Webpack 4 plugin and moved all of our legacy logic to this package. This way, we isolated the legacy features, legacy logics to a separate scope and keeps the core clean and simple. Also, even if we have those plugins and presets, it won't be useful if users never tried to adopt new features, our new versions for the latest features and bug fixes. So we have implemented this couple of commands, Vue upgrade and Vue migrate. If you migrate, Vue upgrade will call Vue migrate underlying it. And this couple of commands is responsible for updating your project setup to the latest new CLI versions, including those that are not under the Vue CLI scope, like outside ESLint plugins and other kind of dependencies in the project. This code snippet shows how we managed to update the ESLint version in the user project. We also have a tool called Vue Code Mod. That is unlike Vue upgrade and Vue migrate that are used for keep project configurations up to date. Vue Code Mod is responsible for keep the code base up to date so that the user can experience the newest features in the Vue ecosystem. For example, here is the example that we use the Vue Code Mod feature to migrate our Vue components to use the newest define component function in Vue 3 so that we can have better typing support. It is currently still under heavy development, and we might ship it in VueCLI 5 under a new command that is used to migrate your Vue 2 projects to Vue 3. Maybe we'll call it Vue upgrade Vue or something. Whenever the user code is upgraded, the burden for us to keep maintaining the old usage pattern is reduced, and we can keep improving our type definitions in the new function. Sometimes a feature grows out of the scope of a plugin. Then we might need a dedicated new tool for it. For example, the instant prototyping feature in Vue CLI. In Vue CLI 3 and 4, there is a Vue serve and Vue build command that is used to develop a single Vue component at any time under any directory. This is quite useful, but it is also confusing sometimes because users might confuse it with the project local Jiang serve command, which is used to serve an app, not a single component. So in Vue CLI 5, Vue serve is just an alias to Jiang serve. For the instant prototyping feature, we think that Vite might be better suited for this usage because of these two reasons. First, Vite only requires 4 megabytes network traffic to download. So it is much smaller than Vue CLI itself. And there is no version discrepancy caused by global installation because every time you create a Vite project, it is served in a local folder instead of from the global node modules. And this way, we can keep the Vue CLI command line itself clean and Vite as a very concise tool has less complexity in implementing such features. And another thing is the library mode. In VueCLI, we support multiple build targets, including web components, multi-page app, single-page app, and the library. The library is a component library that is built from a Vue file or a JS file. But it is also confusing sometimes because many of the features are built into the command line tool rather than the configurations. So we have to designate the component name in the command line flags as a command line option. And sometimes a component library requires a completely different setup from a typical app. Like it shouldn't bundle the polyfills into it, but an app should bundle everything that is required to run in the browser. So it's hard to maintain two separate configs for a for library and apps. So with Vite2, there is a library mode, and we think it is reasonable to only use Vite for libraries because it is more suited for bundling such component for such build targets. Vite also uses rollup underlyingly, and rollup is typically recognized as a better library bundling tool than Webpack. And after all, you shouldn't keep the library and the app in a single repository. Even if they share the same logic, you might want to move some of the library component libraries to a separate folder to maintain. In conclusion, today we talked about several ways to achieve organized complexity so that we can keep maintaining Vue CLI in a sustainable way. The first is to simplify the configuration of interfaces, easing the burden of maintaining a bunch of complex configurations files. The second is to avoid problematic behaviors of third-party dependencies. We do that in two different ways. First, by including dependencies for Babel transpilation. And the other one is to exclude TypeScript definitions from dependencies to avoid annoying interferences so that those problematic behaviors are isolated from the project code. The last one here is to keep the tool itself simple and dedicated. Complex features can either be separated into plugins or to a completely different new tool like Vite. By using these techniques, we can keep a big tooling project like Vue CLI maintainable and get to the state of organized complexity. Thanks for listening. Hope you enjoy it. Thank you.